Let's make that spam classifier we talked about a reality. Go ahead and open up your Jupyter Notebook if you haven't already. From the Anaconda prompt, cd into your course materials directory and type Jupyter Notebook to get to this screen here. Navigate into section 8 and let's open up naivebayes.ipynb. A lot going on here, but most of it's just preparing the data. The actual naive Bayes algorithm itself is actually very straightforward to apply, but let's dive in here. We're going to build that spam classifier. Again, most of the code is just loading our training data into a pandas data frame so we can actually play around with it more effectively, and that's what all this code is doing here. If we take a look at the data that we're given, this is actual real email data that comes from a publicly accessible data set. Let's actually look at our course materials here more directly. That was in C, Self-Driving Materials, Section 8. So our training data lives in the emails folder here, and you can see that we have things segmented into a ham folder and a spam folder. So in the spam folder are a bunch of examples of emails that are classified already as spam. These are just dumps of the actual emails themselves, including all the header data and whatnot. And we also have a ham directory full of emails that are already classified as not being spam. So somehow we need to load all this data up and combine them together into a data frame that we can play with. And that's what all this code is doing here. So first of all, the read files function here is just taking in a path to one of those directories of spam or ham emails. It walks through every single file in that path using os.walk, constructs a full path name to each individual file, and loads it up using io.open. And then for each file, it skips past the first line, which is the header information, and reads in the body of the email, which is the actual text of the email itself, into this line variable here. Okay. We then join each line together into a message that's separated by line feeds. So what we end up giving back is both the full path to that file and the message of the body of that email. And it will just keep returning that one email at a time. We then have this data frame from directory function. That's just a little bit of a convenience here. It actually creates a data frame object from those files. So you can see that it actually calls read files for a given path, which is a path to either the spam or the ham directory. And as it gets back individual message bodies, it will append a row to the data frame that has the actual message body and the classification that we specify as well. So what we're going to get back here is a list of rows where each row represents a message body and a classification of spam or not spam. And we will also have an index list that contains all of the file names associated with each email message. And then we return a data frame that consists of those rows with an index column given by those file name paths. All right, then we just load it all up. We create this new empty data frame called data that contains an empty list for messages and an empty list for classes. We append all of the spam emails into that data frame, and then we append all of the ham emails into that data frame as well, passing in the paths relative to where we are for spam and ham. Let's go ahead and run that. Again, most of the work in machine learning can often just be preparing your data, and that's all we're doing here. Did that finish? It's still running. There's a lot of data here to actually run in. There's a pretty large data set that we're playing with. All right, that finally finished. Let's take a look at what we ended up with. We'll do a data.head to take a look at the first 5 results, and those first 5 are all spam classified emails that came from our spam folder. And you can see it worked. We actually have the path to each individual file there as the index and the actual body of each email as well. So this one's in HTML format. This one seems to be in plain text. And yeah, they're all spam. So now we can actually do the machine learning part of this exercise, which is relatively simple. Okay, so all we have to do here is create a count vectorizer that splits up each message into a list of words. So that's going to be basically converting each individual message body into a list of words and how often those words occur. That's it. And it tokenizes those words into numbers that can actually be used by our mathematical machine learning models. So then we can just create a multinomial NB. That's our naive Bayes model itself from scikit-learn. We will create our feature data set by extracting that class column out of our data frame. And then we will fit our counts data, which came from count vectorizer. That's just a transformation of the feature data that we extracted from the message column of our data frame. And for our labels, we pass in that targets data frame as well. So we're just going to create a multinomial naive Bayes model here. And we're going to train it using this count vectorizer output that is a numerical representation of the words in each email message, and also the class of spam or not spam that came from our class column in our data frame. Let's go ahead and let that run. All right, so we've built our model. That was actually very quick. And now we can actually try it out. So let's actually see if it can predict whether a given new email it's never seen before might be spam or ham. Let's construct this fake email that says, "Free Viagra now," or "Hi Bob, how about a game of golf tomorrow?" So these are my takes at making a pretty obvious spam message and a pretty obvious ham message that is legitimate. And sure enough, if we run this, if we run predict on our resulting naive Bayes classifier, first we have to actually convert those message bodies into count vectorizer results so we can actually use that to train our model with in the same way that we built it. We come back with this set of predictions. So we passed in this array of example email bodies, and we got back an array of classification results. And sure enough, we came back with a classification of spam for the first one and ham for the second one. So that's encouraging. It seems like our spam classifier actually works just based on these two made-up examples anyway. Pretty cool stuff. All right, so let's tie it back into self-driving cars again. So at the end of the day, this is just a classifier, right? So we should be able to apply it to our same problem that we introduced before in the previous section of trying to predict whether your car should travel slow or fast just based on the size and distance to an upcoming bump in the road. So we'll start by fabricating our data set in exactly the same way as we did before to keep things fair and square. So we're going to fabricate this fake data set of vehicles that were driving slow or fast given a given distance to a bump and how big that bump is. So much more straightforward to create a multinomial naive Bayes classifier for this because our data is already numeric in nature. We don't have to actually transform that in any way or load up a bunch of data files of emails and convert that into count vectorizers. We can just plug it right into our model. So let's go ahead and create a multinomial naive Bayes model, fit our entire data set to it. So we're going to train our model using the entire feature data and all the label data we have. And as we did before, we'll plot our predictions based on each individual point in our graph against the actual data points that we trained it with. And we can see it did a pretty good job. It looks very similar actually to the logistic regression results that we had back in logistic regression. Was it actually better or not? Well, let's actually measure that. Let's use k-fold cross-validation to evaluate how well it does. So we'll run cross-val score on our naive Bayes classifier and allow that to split up all of our test data and training data into 5 different folds and evaluate them independently. And it did pretty well, 83%-ish. And, that's not quite as good as logistic regression. We got 84% with logistic regression, but it's close enough that, it's definitely comparable. However, logistic regression is definitely a simpler model. So given the choice between the two, I would go with logistic regression. Not only did it outperform it a little bit, but it's also simpler, and simpler is usually better. But naive Bayes did a decent job here. So it's a good example of how Bayes' theorem can be used for machine learning as well in a pretty straightforward manner. Anyway, if you want to dive into this some more, our data set is small. So our spam classifier isn't really all that good. Try playing with it some more and actually run some different test emails through it that you've made up and see how well it does on classifying real spam emails that you have from your email and real emails that you have that are ham. So very easy to experiment with real emails that you might have just sitting in your inbox. Play around with it, see how well it really does. And if you really want to challenge yourself, try applying train test or cross-validation to our spam classifier. It's not really a good way to evaluate models by just throwing random data points at it and random emails and seeing if you think it's right or not. It's much better to actually evaluate it based on your real test data itself. So see if you can actually modify that code to do an actual cross-validation and not just eyeballing specific random results that you feed to it. All right, play around with that, and we'll move on to another exciting machine learning technique in our next lecture.